By the name of God, most merciful, most kind, peace be upon you all. This is the second video for the linear analysis, for numerical linear analysis. We are going to discuss the LU decomposition. This video is an introduction to the LU decomposition for 2x2 matrix. We are going to follow the Doolittle's method for L and U matrices. The first question, how can we find L and U matrices elements? The components, I mean. Another question, can we have LU decomposition for a singular matrix? As we know, the singular matrix, there is no inverse for that singular matrix. It is only single. We'll move to the second slide. What is the difference between the Doolittle's method and the Crout's method? This is an introduction LU decomposition of matrix to separate it into two components. One is called L, the lower matrix, or lower triangular matrix L, and an upper triangular matrix U. For the lower matrix, if the measured diagonal of the lower matrix is unity, the procedure based on unity elements on the measured diagonal of L is called the Doolittle's method. This is a method adopted by Doolittle, considering that the main diagonal of the lower matrix is 1, while the other method is considering that the diagonal of the upper matrix is unity. This is called the Crout's. We have two simultaneous equations, 2x plus 3y equal to 13 and 3x plus 4y equals to 18. We consider these two equations as ax equal to b, where A is a matrix composed of 2, 3, 3, 4. This is the A. X is a vector of unknowns, and B is 13, 18. We are not going to solve for X and Y values, but we are only concerned by how to determine the components of L and U for the time being. The lower matrix like this, the components L11, 0, L21, L22, the upper matrix like this, and this base is a 0. In our case, this 0 is U21. We have U11, U12, U22. If we are considering that A is equal to the product of L by U, it means that when I multiply this by this, I will get the value of A. So each component can be represented by the product of L and U. Besides how many unknowns we have, we're supposed to have 6 unknowns, but due to Doolittle's method, we have L11, L22 equals to 1. So we have only, for the time being, we have 4 unknowns. These unknowns are L sub to 1, U sub 1, U sub 1, 2, and U sub 2, 2, based on the Doolittle's expression. We'll move to the next slide, in which we are going to find out these 4 unknowns. Again, this is the components of L matrix, and this is a component of U. And this is the A, 2, 3, 3, 4. If we are going to multiply both two matrices by each other, we multiply 1, 0 by U1, 1. So we have U1, 1 in this upper left corner. And we have U1, 2 plus 0 by U2, 2. So we have only U sub 1, 2. And when we multiply the second row by the first column, we have L sub 2, 1 by U sub 1, 1 plus 0. It will be here. And L sub 2, 1 by U1, 2 plus U2, 2 will be here. Basically, each element of this matrix equal to each element of the product matrix. So we have 4 equations. The first equation, that U11 equal to 2, and u12 equal to 3, and L sub to 1 by u11 equal to 3, and L sub to 1 u12 plus u22 equals to 4. These are the 4 equations. We'll start by the first equation, that u11 equal to 2, which is very straightforward, will give us the value of u11. The second equation, u12 equal to 3, which will be here. From the first glance, we'll find that this one equal to this, and this one equal to this. So this is a quick notice to determine these two values. Okay. We'll move to the third equations, which is L sub to 1 multiplied by u11 equal to 3. Since we have u11 equal to 2, so L sub to 1 equal to 3 divided by 2, which is that one. 3 divided by 2 will give us L sub to 1. For the last equation, the fourth one, we have L sub to 1, u sub 1 2 plus u sub 2 2 equals 4. We are going to use whatever elements we have. L sub to 1 is 3 over 2 multiplied by u12, which is 3, plus u22 equals to 4. So u22 equals to 4 minus 9 divided by 2. So we have minus 1 over 2. We'll move to the next slide. From our observation, we have listed all the values for u11, u12, L sub to 1, and u sub to 2. If we divide this by this, we get this corner. We have 1 corners, and this is 0. These two elements go straight directly to the upper and left corner. 2 goes here and 3 goes here. The problem lies in here. This one is this equals to a sub 2 minus 3 over 2 by u12. This is u12, the corner. As if there is a pivot here, we are going to use. So u22 equal to minus 1 and 2. In the next slide, we are going to talk about the singular matrix, which we have no inverse. Is the statement, not all the square matrices have LinearNumericalAnalysis decomposition. It may be necessary to permute the rows before obtaining LU factorization. He's talking about the case that you have like this. This one is, if we are going to permute, it will not make any difference, but maybe the case of if we have a 0, a11 equal to 0, this is a partial pivoting that we are going to permute the rows, but we will discuss later on. Anyway, this B is a singular matrix. Why it is a singular matrix? Because if the determinant value is 1 by 10 minus 2 by 5 equal to 0. In order to get the LU decomposition, we start to write that we have 1 and 1, L to 1. Again, we have 2 corners equal to 1, and this L to 1 is 2 divided by 1. L to 1, A to 1 over A11 equals to 2. So we have now, this is 1, and this is 2. We'll move to the next slide and determine the values of the upper matrix. As we can observe that this is the matrix P. This element goes to here, and this element goes to here. So this is the value of U11, and this is the value of U12. While here U22 will be equal to A22 minus L21, L sub to 1, which is 2, multiplied by this, the pivot, which is 5, 10 minus 10 equal to 0. We'll come to the situation where we have 1, 0, 2, 1, and 1, 5, and 0. If we multiply L by U, it will give you the matrix. But since this corner is 0, and that cannot be accepted because we have an upper matrix, U11, U12, and U22 should have a value. So this is not acceptable, and we cannot consider that this matrix have LU matrices. We come to the end of this video. Thanks a lot, and for the data of that video will be presented. It's already published in one link of my website. I will put that link in the description of this video. Thanks a lot. Goodbye. God bless you all.